All right, today is May 13th, and we're going to start talking about the last unit in Calculus BC. And we start off with this thing called parametric functions, and it's day one, okay? And what parametric functions do is it tells you about how like a particle or a point moves in a plane, okay? So that's what we're going to do, two-dimensional, okay? But these actually come in three dimensions. Like if you want to know where a particle is, like in space or on a plane, okay, you need to know what the the horizontal coordinate is, the vertical coordinate, okay, and those depend upon a time. Okay, so we're talking about movement of a particle, okay? So like a particle could start right here. Okay, so that's the starting point. Let's just call that IP, and I'm calling it IP because it's the initial point. Okay, that's what IP stands for. Okay, so this particle could be moving, right? And it could be moving up and right at the same time and down, and it could do some loops, and it could come down, and it's just moving on this paper, okay? And you could come back around, and then you end up right here, okay? And this is the terminal point, okay, which we call TP, okay? Not toilet paper, terminal point, okay? Terminal point. Okay, now we have to know if we have an initial point and a terminal point. Sometimes it's hard to see what direction we went, okay? So what we do is we put arrows along the path that we're going. So it started right here and we went this way, right? And then we went this way. And then especially when you start doing these like loops and stuff, okay? And then it came down this way and came this way and came this way. And we put arrows just so somebody can see the direction in which this went. So there, and then back down this way, that way. Okay. And I'm putting a lot of arrows. You don't usually have to put this many arrows. Okay. But just to show you, okay, the initial point, that's where we start. And you can tell by the arrows too, that that's the point we started at. And then we're moving along, we're moving on this piece of paper, right? And the piece of paper is a plane. Okay. So to know the position of anywhere on this paper, okay, I would need to know, well, I need to know where the origin is, right? Where the starting is, okay? And I would need to know how far I'm left or right of that point and how far up or down I am from that origin, okay? So like I can make it like be this upper left, that'd be the origin, okay? And I would have to go to the right and I would have to go down on this, right? And then what we know is from the X and the Y, okay, that those are dependent upon a time, okay? So like I was moving and and there was like if you started the stopwatch, like 1 second later I'm here, and that's how far I am from this from the origin to the right, and how far up or down I am from the origin. Okay. So we're going to do some sketches. You have some graph paper in your packet. Okay, and I should say this, all of this is from the first packet from March 16th, okay? So I didn't know that they were going to cut all this out of the AP exam, so I had put it in the first packet, okay? So you need to refer back to that. I'll do PDF copies of all this, so in case you lost it, you can print something, okay? Or so I am going to require you, okay, to send me a PDF copy, okay, of the notes and also the homework, okay? And you're going to submit them all as one PDF document, okay? All right. So you're going to get points for both, okay, for completing the notes and also for completing the assignment, okay? All right, let's come up here and let's do this first problem, okay? All right, so I want to be able to sketch the parametric curve and identify whether y is a function of x, okay? And then we're going to do a second part, and that's going to be eliminate the parameter to find an equation that relates x and y. So right here, okay, x is dependent upon, okay, the time minus 2 and the square root of that. And the y, it depends on the time plus 5 divided by 4. And we're going to give you this time interval, and I'd have to give you this time interval, like when do we start this and when do we end it? So we're going to start it at t equals 3, and we're going to end it at 27, okay? So our first t value is 3, and our last t value is 27. And I'm also going to show you how to put these in your calculator, okay? Because we have a parametric mode in our calculator, okay? All right, and these are going to kind of have to do with vectors also that we're going to do next, okay? And those are going to be those you used in physics, okay? All right. Okay, so first of all, we got to figure out what the coordinates of our initial point, right? And for our initial point, I'm going to write this. Our initial point is t is equal to this 3 right here, okay? So t is equal to 3. Okay, so what's the x and the y coordinate, okay? So our x is equal to the square root of 3, because our t is 3, minus 2. That'd be the square root of 1, which is 1, okay? Now, what's the y coordinate at t equals 3? So we got to do y is equal to, and this would be 3 plus 5 divided by 4. And I'm doing a really simple one at first just to get you going on this, okay? And 3 plus 5 is 8, and 8 over 4, and 8 divided by 4 is 2, right? So the initial point is the point 1 comma 2, okay? So 1 comma 2, so the grid down here is scaled by ones on both the x and the y axis. So 1, 2 would put me right here. At time t equals 3, that's where the particle is, okay? That's the location on this plane, okay? Now, let's figure out the terminal point, okay? So the terminal point, the ending point, and these are the easiest to do first, okay, would be at t is equal to 27, okay? So that would mean x is equal to the square root of 27 minus 2, which is the square root of 25, which is 5, okay? So I know at t equals 27, the x coordinate is 5, and the y coordinate would be 27 plus 5 divided by 4. And then 27 plus 5 would be 32 divided by 4, and that's 8. So the terminal point where this ends is at 5 comma 8. Now the problem is, and let's go ahead and plot that, okay? Let me just go and do that before I talk anymore. Okay, so right here at 5 at the end, okay, and I should write this. This is the initial point, IP. And then the terminal point is at 5, 8. So here's 5, and then 8 would be right here. And this is be the terminal point. This is where we end. Okay, and then here's the problem with this. How did it get it? Okay, so we know it started here and we know it ended here, but how did it get here? Did it go on a straight line? Did it loop and come? Like, we don't know. So we would have to do a heck of a lot more points to figure that out, like a lot more points, okay? So I'm actually going to do one more point, okay? And one more point that I'm going to do is and I want to pick a number that's I'm going to be able to subtract 2 and take the square root of really easily, okay? So I would say something, and some time value between 3 and 27, okay? Let's do 11, okay? I'm going to do a couple points here, okay? So another point would be t is equal to 11. Why? Because if I take 11 and minus 2, that would give me 9. Now I'm going to be able to square root, okay? So t equals 11, okay? And that would mean my x is equal to, okay? Sorry, I went blank there. Okay, x is equal to, sorry, square root of 11 minus 2, which would be the square root of 9, which is 3. And my y would be 11 plus 5 divided by 4, and that would be 16 over 4, which is 4. So a point that's in between is 3, 4, right? 3, 4 right here. So now you can tell it's not a straight line, right? You should be able to tell, right? Because if it was a straight line, we'd be going through this point and this point, right? So it's not, it's curved, okay? So I'm gonna draw this, okay? So you could do another point. Let's do 17. 17, okay, if we did 17, why am I saying, no, 18, sorry. 18. 18 minus 2 would be 16, right? And that would give me 18 minus 2 would be square root of 16, and x would be 4, right? So x would be 4, okay? And if I did 18 plus 5, and see, this wouldn't come out to be nice, okay? So 18 plus 5 would be 23 divided by 4, right? And that, you could do it with a calculator and get a decimal approximation, right? But it doesn't give you nice numbers, okay? All right, so I changed my mind. I'm not gonna do that, okay? Sorry, all right? So we started here and we ended here, and we need to go through this point, okay? So basically that's it, okay? So I'm just gonna connect it. I'm gonna go through this point, and then I'm gonna curve it because I have to curve to get to this point, right? And we started here, so I'm gonna start drawing my arrows, and we came this way, right? And we ended right there, okay? And I probably did more arrows than you really need. When I did these notes in the past, I just did 3 arrows, okay? So what did I do this time? 5? You know, 2 arrows is enough, okay, on something like this. Like if I put an arrow here, that's good enough, okay? All right, now, so right now, the way this looks, okay, it looks like y is a function of x. That means for every x, there's only one y value, right, in the vertical line test, okay? All right, so what we want to do next, okay, is that we want to eliminate the parameter to find an equation that relates x and y. So I want to go back to write an equation with x and y, okay? And how you can do that is, one way that I would do it is, I would solve the x equation for t, and then take that t, because the t's are going to be the same, this t and this t are the same, and then take that t that's in terms of x and replace it right here, okay? So, okay, we are going to solve, this is part B, okay? We are going to solve x is equal to the square root of t minus 2 for t, okay? Now, this isn't always going to work, okay? But for a simple equation like this, it will work, okay? So what we'd want to do is we'd want to square both sides, and that would give me x squared is equal to t minus 2, and then I'd want to add 2 to both sides, so that would give me x squared plus 2 is equal to y, all right? Now, sorry, not y, t, right? So I add 2 to both sides, and be x squared plus 2 is equal to t, okay? Now, how do I get y? Okay, so I need y, but I need it in terms of x. Well, I know t is the same as the x coordinate squared plus 2. So I know now that y is equal to t plus 5 divided by 4. Okay, and I'm going to replace this t with x squared plus 2. So this becomes y is equal to x squared plus 2 plus 5 all over 4, okay? And that would be x squared plus 7 divided by 4. Or another way of looking at this is y is equal to 1/4 x squared plus 7/4. Okay, so what is this? This is a parabola, right? And so that's what the shape is, okay? All right, this curve is moving along a parabola, okay? Or the particles moving along a parabola, okay? And you didn't know that from up here, right? Okay, and that's what's important, okay? So this just describes the x, the location of the x and the y, okay, coordinate of this particle or this point, okay, at any given time, okay? So if we went to 3 dimensions, okay, you would have, in terms of time, okay, you would tell, you would say how far it goes left or right, how far it goes up or down, and how far it goes front or back, and that's a 3rd dimension, right? So that'd be 3D, and that would produce this a 3D curve, okay? So a lot of times when they shoot rockets up, okay, they tell you the altitude of the rocket, and they tell you something called downrange, and that's the horizontal distance it's moved from the launch pad, okay? And they give you its downrange, like, 2.3 miles, altitude of 5,600 feet or something like that. And they're telling you, basically what they're doing is they're telling you the x coordinate and the y coordinate for some time, okay? So let's say at t equals 3 minutes, plus 3 minutes, the rocket is downrange 2.5 miles and with an altitude of 7,836 feet or something like that, okay? So that's a perfect example of where this is used. Okay, so it gives you the distance down, horizontally from the launch pad, and then how high it is. Okay, you could go 3D with it too, and go how far, north or south and all that. Okay, this is used in GPS too. Okay, all right, global positioning satellite stuff. Okay, because you need an X, Y, and a Z, and even more coordinates than that. Okay, that's future calculus classes that you'll take. All right, okay, let's go to example 2. Okay, I take it back. I don't want to do example 2 quite yet. Okay, I actually want to show you how to do this in the graphing calculator so you can look at what's going on. Okay, all right, so what I want to do is I want us to press the mode button. Okay, and then come down to the, what is it, 4th line, 5th line, 1, 2, 3, 4, 5, 5th line, and you see where it says functions highlighted. We want to highlight parametric. Okay, so let's come down here and highlight parametric. Okay, now this graphing calculator is on a computer, so the processing speed is a lot faster than your calculators. So I'm going to need to find a way to slow it down, and I'll show you. So because I want you to be able to see the movement. Okay, so if we now press y equals, look what happens. We get an x sub 1 and a y sub 1. Okay, so for us, x sub 1 in terms of t, right? It was the square root, so we press square root, and it's going to be, and we press the x button, but it won't give us an x, it's going to give us a t. Okay, so t minus 2, because that's our x coordinate in terms of time, and our y coordinate was, it was a fraction bar, right? So fraction, and then it was t, and then plus 5, and then divide by 4. Okay, now I'm going to set my window up. We set our t min. We started at 3, right? And our t max was 27. Okay, and our t step. Okay, I'm going to try this. I'm going to try 0.001. This might be too fast. It might be too slow. Okay, I don't know yet. Okay, so I'm going to go x min, and from the graph, our x min was -1. Okay, and then our x max was 10. And then our x scale, let's go by 2s. Let's go by 1s. Okay, and then y min is -3. And then our y max was 10. And let's scale that by 1s also. Okay, and now when we press graph, it's going to produce the graph that we have. Okay, so I'm going to press graph, and this might be, okay, I don't know, this might make it go really, really slow, or it might make it this t-step. What that means is it's going to plug in 3 like we put in t equals 3, t equals 11, and t equals 27, right? It's going to put in 3.001, 3.002, 3.003, 3.004. I'm doing this many decimal places to slow it down so you can see it. I might be slowing it down too much, and I'll pause it and I'll go back and fix this and go like 2 decimal places. Okay, so I'm going to press graph and see what happens. Window range. Let me see what happened. 3 to 27 t-step. -1 to. Maybe my t-step is too big. Is too small. Let's do that 0.01 and delete that last one. Now let's press graph. There we go. And that's slow enough. Okay, so there, it's done graphing because it plotted every point from t equals 3 to t equals 27. And look what it did. It put us at 127, or not 127, 1,2, and then 5,8. And you can even press, I believe you can press trace. Yep. So at t equals 3, the x coordinate is 1 and the y coordinate is 2. We can scoot across, right? And it's going by pixels. And there's a lot of pixels here. Because if you look at this t is going up by 0.01. So it's going to take, let's see if we can press 5. Yeah, t equals 5. And that's what our x and our y coordinate be. So let's put 27. And that'd put me at the end. Okay? So you kind of understand how this works, right? Okay. All right. So that one wasn't that bad. Okay. We're going to need to use trig identities and some stuff to figure some other stuff out. Okay. So now let's go to example number 2. So for example 2, again, it's the same thing. We want to sketch the parameter curves and then identify whether y is a function of x. Okay. And then eliminate the parameter to find an equation that relates x and y. Okay. All right, so this one, the x coordinate is 2 cosine t, and y is equal to 3 sine of t, and the interval is 0 to 2 pi. Okay, so our initial point is going to be at t equals 0. Okay, and that would be x is equal to 2 cosine of 0. Now, cosine of 0 is 1, okay, and 1 times 2 is 2. So the x coordinate would be 2. And the y would be 3 sine of 0, and sine of 0 is 0, so 0 times 3 is 0, okay? So the initial point is 2 comma 0, okay? That would be this point right here. And that's my initial point, okay? Now, the terminal point is going to be at t equals 2 pi, okay? I'm actually going to do I'm going to pick angles. I'm going to do another points and then do the terminal point at the end, okay? So another point, another good angle that would be easy to work with, okay? And you want to pick t values that are easy to work with, okay? We did 0, pi over 2 would be another good one, okay? So another point, and some people make tables for this, okay? T equal to pi over 2. So that would mean x is equal to 2 cosine of pi over 2, and y would equal 3 sine of pi over 2. Okay, and so 2 times cosine of pi over 2, well, cosine of pi over 2 is 0, so that'd be 0 times 2, which would be 0, okay? And so we started here, and then we're going to end up where? We're going to end up at 3, right? Because sine of pi over 2 is 1, and 3 times 1 is 3. So that'd be 3. So that'd be 0, 3. That's going to end up right here at that point. So we're going to start here, and we're going to end up right here, okay? Now we need to do another point. Another good point would be pi, okay? That'd be easy to work with. And so another point that we could use is t is equal to pi, okay? So that would mean x is equal to 2 cosine of pi, and your y would be 3 sine of pi. So cosine of pi is -1, and 2 times -1 would be -2. And then 3 times sine of pi is 0, so 3 times, that'd be 0, right? So that would put me right here. Okay, so I started here, then I made it to right here, and now the particle's right here, right? And this is a bigger time than pi over 2, right? And then if we keep going, we could do 3 pi over 2, right? Okay, so another point would be 3 pi over 2. The more points you do, the more accurate graph you have, okay? So t is equal to 3 pi over 2. That would be x is equal to 2 cosine of 3 pi over 2. And y is equal to 3 sine of 3 pi over 2. Cosine of 3 pi over 2 would be 0, okay? And then 2 times 0, that'd be 0. Sine of 3 pi over 2 is -1, so the y coordinate would be -3, so that'd be this point right here, okay? And so we started here, then we went to here, then we went to here, and then we went to here, right? And so let's end up at t is equal to 2 pi, right? So another point is the terminal point now. Okay, and that would be t is equal to 2 pi, sorry. I started to do 3 pi over 2. So 2 pi, right? So x would be equal to 2 cosine of 2 pi, and your y coordinate would be 3 sine of 2 pi. Well, cosine of 2 pi is 1, so this would be 2, And sine of 2 pi, let me slide that up a little bit. Sine of 2 pi would be 0, and 3 times 0 is 0, right? So this point would be 2 comma 0, right? And I should have been putting points. So this point right here is 0 comma 3. This point right here is negative 2, 0. And this point is 0, negative 3. And you know what? I should say this. When we graph this, you don't see the time at all. You don't see, that's why we need the arrows. You don't visualize. There's no time on here. It's just an x and a y for a given time, okay? Just like if you had a particle and you like at the very beginning where we drew it, okay, you wouldn't know, okay, you don't see the time on that. You see position, but you don't see time, okay, and that's why we need the initial point and the terminal point, okay. So what happens is we end up back where we started right here, right? So the initial point and the terminal point are actually the same, okay. Now, if we did some more points, we'd get better resolution of this, right? Okay. But what's happening is it's kind of making this oval shape. And I'm going to tell you, it's called an ellipse. Okay. So right here, there's a vertical tangent. And right here, there's a horizontal tangent. And right here. And we're going to do derivatives of these in just a little bit. Okay. So we would know that when we do calculus on this, like we would know that the derivative would be 0 right here. Okay. All right. So I'm going to draw it so it looks like this. Okay. So it came in like this. Okay, and I want to say this. You would not know right now with your knowledge, you would not know that that's horizontal right there. And you wouldn't know that this is vertical right here. Okay, so we start right here. And when we go to this point, and then we're working to this point, and this one's vertical too. Okay, so it looks kind of like this. And then here, right? And then it's going to get to this point because that was the third point. And down here, it's horizontal. Okay, so it's coming this way. It's coming this way, it's coming this way, and then it turns and it comes back up, okay? And that's the terminal point right there, okay? So it looks something like this, okay? Now, rewriting this, relating to x, y, and I should say this, is y a function of x? No, it's not, right? Y is not. Okay, and what that means is we are not going to be able to write this as y equals, okay? Y equals a simple equation, okay? All right. So what we do, and we have to treat this one differerently because it's trig functions, okay? Okay, so what we have to do is we know that x is equal to 2 cosine of t, okay? And then we also know that that y is equal to, sorry, I'm thinking, okay, 3 sine of t. Okay, now what I'm gonna do is I'm gonna divide both sides by 2. Now I'm not gonna get to t by itself, okay? But I'm gonna use this, okay? Well, let's just work it out, and I can talk our way through it, okay? It's hard without you showing an example of this, what we can do. So what we can do here is divide both sides by 2, and that would give me x over 2 is equal to cosine of t, okay? And over here, I'm gonna divide both sides by 3. So that would be y over 3 is equal to sine of t. Okay, now, what I'm gonna do next is I'm gonna square both sides, okay? If I square the left side and then square the right side, they will stay equal, okay? All right, so if you have trig functions, okay, you're gonna wanna get cosine by itself and square it, and you're gonna wanna get sine by itself and you're gonna wanna square it, okay? You'll see in a minute why, okay? So right here, okay, I'm gonna square both sides. That would, well, let me just go ahead and write it. So x over 2 squared is equal to cosine of t squared, okay? So this left side would be x squared over 4 is equal to cosine squared t. Over here, I'm going to square both sides just like I did over here. So sine of t squared. Okay, I'm squaring both sides, so it's going to stay equal, okay? So this left side becomes y squared over 9. You're going to see this in a minute. It's slick, I think. Okay, so how, okay, Mr. Mitchell, like that's all great, but how does that get me an equation with x and y? Okay, we're going to use a Pythagorean identity, okay, to figure this out. And this is why I squared the cosine and I squared the sine. we know that cosine squared theta plus sine squared theta is equal to 1, right? We know that, right? So it doesn't matter if it's thetas or t's, right? We would also know that cosine squared t plus sine squared t is also equal to 1. How does that help you? Well, here we go. What is cosine squared t? Well, it's x squared over 4. So we replace this with x squared over 4 plus, what is sine squared t? It's y squared over 9. So y squared over 9 is equal to 1. And there's your equation that relates x's and y's, okay? So we got to use the Pythagorean identity for this, okay? And this is called, when this equation, we have x squared over a number plus y squared over a number, and it's equaling 1, that's called an ellipse. That always produces a graph that looks like this. That's kind of, it's not an oval, but it's kind of oval shape, okay? It's, if you think of a circle and stretch it in one direction, that's an ellipse, okay? So like if we went up from -2 to 2, okay, instead of from -3 to 3, see how it got stretched vertically? If it went from -2 to 2, that'd be a circle, right? So if you take a circle and stretch it either in the vertical direction or the horizontal direction, that's an ellipse, okay? All right, and this is, I'll write this. This is an ellipse. That's just knowledge, okay? That it's called an ellipse. All right. Okay, so let's go to example 3. You could put this into your graphing calculator, and your Tmin would be 0, your Tmax would be 2 pi, and I would do something like 0.01, okay? 0.01 actually might take your calculators a little bit of time to graph, so you might change it to 0.1, okay? And what happens is you don't get as good as resolution. You kind of get these little like line segments if you don't do enough. Like if you did 0 to 2 pi in your scale, your t scale was 1, or your t step, it's called t step, and your t step was 1, you're not going to get a lot of resolution, okay? Because you're not doing very many points, okay? Actually, I'm going to go to my graphing calculator and I'll show you this, okay? So this time we want to go to y equals, and let's clear out the equations we have. And let's go, x was 2 cosine t, so 2 cosine t, and y was 3 sine of t. And window, okay, so our window, let's go from -4 to 4 by 0.5, okay? So x min is 0. That's where we want to start it. And t max is 2 pi. Let's do t step of 1. Okay, so that's going to go, it's going to plot 0, and then 1, and then 2, and then 3, and then 4, and then 5, and then 6. And you're going to see it's not very good resolution, okay? And then let's do x min of -4, x max of 4, x scale of 0.5, y min of -4, y max of 4, and 0.5. And let's press graph. And you see how, and it doesn't even come back and complete, right? Because you went to 6, right? Okay. And you didn't go all the way to 6.28, which is 2 pi. Okay. And you see how like this doesn't look like what I graphed, right? Okay, watch what happens. If you go to window, and that's why I'm showing you this. Okay, if you go to window, and instead of doing 1, let's do 0.1 step. Okay, and you're going to get better resolution because you're doing more points. Okay, what it's doing is it's like when it was t step of 1, it would put 0 in for t and then 1 in for t and get your x and your y and connect those 2 points. Okay, so this is going to connect more points. Okay, it's kind of like arc length, like how we integrate arc length and we broke it up into little segments and we added all the little segments up. Okay, so that's kind of how it does it. Okay, so let's graph this one. Okay, so it's still not quite, you know what, I need to, let's do zoom, and let's do zoom square, and you're gonna see, there we go. So that's not bad resolution right there. The still, it's not going quite to 6.28, right? It's not getting, that's why there's a little gap right here, okay? So if we go to window and we do a t-step of 0.01, we're going to get even better resolution, although that wasn't too bad what we just had. And see now what happened, it connected it because you're getting closer to 6.28 because you're 0.1 away, 0.01 away, okay? All right, guys, so that's what it looks like, okay? And that's and you notice it went in this direction, right? So it went from here and came up along this curve, and then and then here, and then came down here, and right. So, I mean, you can, the more points you graph, the plot, the better resolution you have, okay? All right, and that's the key to this, okay? The next problem is going to be really hard to do by hand. We're going to have to go to the graphing calculator, okay? So I'll talk about that in just a minute. Okay, so for this problem, example 3, we're going to do, it's the same problem, okay? Just different parametric equations, okay, or functions, okay? And I left this off. This should be 0 to 2 pi on the interval 0 to 2 pi. Okay, so the t is going to start at 0. That would be our initial point, right? Okay, so our initial point would be t equals 0, okay? Okay, and normally we do like pi over 2, you know, we would go by pi over 2s, but because the 2 here, I'm going to do pi over 4s, okay? So for this initial point t equals 0, okay, we would have x is equal to sine of 0, okay, and y would equal sine of 2 times 0, right? And 2 times 0 is still 0, right? So both these are going to be the same, okay? They're both sine of 0. So sine of 0 is 0, okay? So we are starting right here on the origin, okay? All right, now I'm not going to do all the points, okay? But another point that I would do, okay, is I would do, okay, I'm looking at this one, I would pick pi over 4 because 2 times pi over 4 becomes pi over 2, okay? So if I did another point, I would do t, another point, would be t is equal to pi over 4, okay? And then that would be x is equal to sine of pi over 4, okay? And the sine of pi over 4, okay? And then y would be sine of 2 times pi over 4, which would be pi over 2, okay? And so sine of pi over 4 would be 1 over the square root of 2, which is the square root of 2 over 2, okay? And then that would be 0.7. So I'm going to write that's about 0.7, okay? And then sine of pi over 2, well, that would be 1, right? So at pi over 4, we're at 0.7, which would put you right about here, okay? And we're up 1, right? So we're all the way up here. Okay, so that's the second point, okay? And then another point that I would do would be t is equal to pi over 2. Okay, and you know what, you could make a table, and you know, you could do this with a table too, like you'd have t values, x values, and y values, okay? So this would be x is equal to sine of pi over 2, and the y would be sine of 2 times pi over 2, which would be pi, right? It's always going to double this one, right? Okay, so sine of pi over 2 would be 1, and sine of pi is 0, okay? So we're at 1, 0. That's the next point, right? Okay, so we started here, we went to here, and now we're here, okay? And so it like, what's going on, right? So this is a little bit hard to see because you'd have to do a lot of points to really see what's going on. But we know we're starting here, and we're going here, and we're going here, okay? And then if we did more, like the next one I would do would be 3 pi over 4, okay? And sine of 3 pi over 4, okay? Both. So let me do 3 pi over 4, okay? So another point, and then that'll be it, okay? and then we'll look at the graphing calculator. Because this is not the important thing, okay, is that you can graph these, okay? All right, so sine t is equal to 3 pi over 4. This is just to get you understanding parametric functions, okay? So another point is t equals 3 pi over 4, right? Because this was 2 pi over 4, okay, 3 pi over 4. And so x would equal sine of 3 pi over 4, and y would be twice that, right? So that'd be sine of 3 pi, well, 6 pi over 4, which would be 3 pi over 2. So sine of 3 pi over 2 is -1, okay? Sine of 3 pi over 4 would be 1 over the square root of 2, which is the square root of 2 over 2, right? Which is about 0.7 again, right? So my x would be 0.7, right? But I'd go down to -1. I'd be down here, okay? So it went from here to here to here, now to here, right? So it's kind of coming back and looping, okay? So I'm gonna go to the graphing calculator and I'm gonna show you this graphically, okay? Okay, so we're gonna go to y equals, and this time we're gonna type sine of t and delete that t, extra t there. And then delete this one, that 3, and then make it 2t. So 2t, right? Because y was sine 2t, yeah. And then close a parenthesis. Okay. And we want to go, let's go window, and we want to go 0 to 2 pi still. Okay, t step of 0.01 is good. Okay. Let's do an x min of -2 to 2. And scale of 0.5 would be good. And y min -2 to 2. And 0.5 scale would be good. Okay, so let's press graph. And so it kind of looks like this infinity symbol, right? Okay, it's kind of cool. All right. Okay, so there's some symmetry going on, right? Okay, so I'm going to slow it down. I'm going to go back to window. I'm going to make this point. Well, actually, let me see if we can watch it again. Let's watch it one more time. No. I'm going to do an extra one just to slow it. This I think will slow it down, okay? Yeah, there we go. So in the upper quadrant, right, upper right, and then the lower right, and then the upper left, it's kind of this figure 8, right, on its side. And then the lower left, right? And it ended. Okay, so I didn't do the terminals point, okay? But if we put 2 pi in here, it would put us back at 0, 0, okay? Now, one thing you could do, okay, is you could look at the table for this, okay? So, like you could go window, this, now you don't want to do this for the table, okay? Not for graphing, okay? Let's do t-step, come down here, and let's do a t-step of pi over 4, okay? So pi divided by 4. Actually, you could do this graphically, okay? And then if you go to table, and you know what? Our table set, we want this to be on auto for doing this. And you know what? There's not enough resolution. Okay, so pi over 4 isn't enough. You see how it's not smooth, right? Because it's only doing this point, 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 and it's just trying to connect them. Okay, so let's go back to. Actually, here's the thing though. Okay, so here's the table of values, right? And here's your t values, and here's your x values, right? And you can go through and you can look at the different ones, okay? So right here, this is pi over. See, it doesn't give you pi over 4, okay? But the t-step is pi over 4. So you know what? You have to go to table set. Because I knew, okay, this delta table. Okay, sorry. Okay, delta table, this is the one that needs to be pi over 4. We were doing the graph of pi over 4, right? So this one needs to be pi over 4. And now our table will be right. Because the x values on our table weren't working. There we go. Okay, so this is pi over 4, and that's my x and my y. This is 2 pi over 4, which is pi over 2. And there's my x and my y, and so on, right? And so we can see, I mean, this, when you see this, okay, that's really close to being 0. So this would be like 0, 0, okay? And 6.28 is 2 pi, right? Right there is 2 pi. So it's 0, 0 again, okay? Okay, so let's go back and okay, so from looking at the graph, we could tell that over here, when it's negatives, there, this next point would be here, and the next point would be up here, right about here. Okay, and the next point would be down here, and the next point would be right here, and then we'd come back up, okay? So this is the initial point, right? I know I'm gonna graph in here, okay? So it's gonna look something like, and it's gonna look something like this. And then come back up, and then come through this point, because we saw this on the graphing calculator. That's the only reason we saw it on the graphing calculator, right? And then come back up. Okay, so the direction it took is, and that's why these directions are important. It went from here to here to here to here to here to here. Maybe put an extra one there. To here to here, and then here, and then here, and then right here is also the terminal point. Now I didn't show that, right? Okay, all right, but the terminal point would be when t is equal to 2 pi, and that would be x is equal to sine of 2 pi, and y would equal sine of 4 pi. 2 pi and 4 pi are coterminal angles, right? So these would both be 0, right? So we start here and we end here at the same point, right? And we actually hit that point one more time, right in the middle, okay? So because we're coming here and then down here and then back here to the 0, 0, and then this way, and then coming back, and we end here, right? Okay. All right, hopefully that kind of made sense, okay? All right, so now we got to write the equation, right? And this is not, I should say, y is not a function of x. I'm going to go back to example 1 and state that, okay? Because I realized I didn't state that on the first example. I said it, but I didn't write it, okay? So how do we go about doing this, right? So we have x is equal to sine of t, and we also have y is equal to sine of 2t, okay? Now, for this one, okay, we want, okay, so when you see trig functions like this, you want to somehow rewrite this with sines and cosines, okay? All right, so this one can be rewritten. There's a trig identity. If you look at your identity sheet, this is the double angle formula for sine, okay? So if you recall, this would be y is equal to 2 sine of t cosine of t, okay? All right, so how's that going to help me? Okay, so right here, I want to get cosine by itself, okay? So over here, y over 2 sine of t would equal cosine of t, right? And here I have sine of t. So I want one of these to be sine t, and I want the other one to be cosine t, right? Okay, now there's one more thing we can do, okay? Is sine t, well, what's sine t? This sine t right here can be replaced with x, okay? So this becomes y over 2x is equal to cosine t, all right? Now, what I want to do is I want to use the Pythagorean identity, right? Okay. All right. And I should, this was the double angle identity. I should have said that. Well, I said it. I should have written it. Okay, so what I'm going to do is I'm going to square both sides. That would give me x squared is equal to sine squared t, right? Over here, I'm going to square both sides, and that would give me y squared over, okay? And if I square y, that'd be y squared. If I square 2x, that'd give me 4x squared. is equal to cosine squared t. And then I know if I take cosine squared t plus sine squared t, I know that's equal to 1. And I just realized you can't see it, okay? So cosine squared t plus sine squared t is equal to 1, okay? So cosine squared t can be replaced with y squared over 4x squared. Plus sine squared t can be replaced with x squared. And this is equal to 1. Now, something you could do is you could rewrite this. And that's, if you left it like this, that's an equation that relates x and y. It's an equation that relates them, okay? I'm going to get it so it's a little bit more simplified. I'm going to multiply both sides of this equation by this denominator 4x squared. That would mean I need to distribute the 4x squared to both these terms. That would make this first term y, just simply y squared, plus, and I'd have to multiply this by 4x squared. So that would give me 4x to the 4th is equal to, and then 1 times 4x squared would just be 4x squared. Okay. So I could get y squared by itself, but you see why this is not a function. Okay. I could get y squared by itself, and then I would have to square root both sides to get y by itself. But when I square root it, I'm going to be square rooting, and that would give me the absolute value of y, which would give me two answers, plus or minus, right? So for some x's, there's two different y values that you could get out of that. One's positive and one is negative, and that's why we're getting these two for the same x, right? For 0.7, we got this y up here at 1, and we also had a y down here at -1, okay? And that's what's causing it. I was pointing to these 2 points, okay? Points like square root of 2 over 2, right? That's what this x coordinate is. It's up here, and it's also down here. So x is square root of 2 over 2, or 1 over the square root of 2, okay? It has a y coordinate of 1, but it also has a y coordinate of -1, okay? All right, so I wouldn't go any further. That's it for writing an equation with x and y. And this comes down to why we needed all those trig identities back in Honors Math 3, okay? We need a lot of this stuff for what we're doing now, okay? And for some integrating that we really didn't hit on, okay? But you'll get it in your future calculus class, okay? All right, so that's it for just the basics of parametric functions, like understanding parametric functions. This is usually done in a pre-calculus class, but Honors Math 3 covers a lot more than we can get through, and we can't get through this in like pre-calc or Honors Math 3. Okay, so I'm gonna go, and now we're gonna do the calculus on this, okay? And that's actually easier, okay? So let's go to the next. I just lied, so we're not going to the next example. We have to come up with the formula for the derivatives. It's not that hard, okay? So, all right, so these parametric curves, we have curves, right? They have tangent lines, okay? So what is dy over dx, right? How do you calculate dy over dx? Now you could switch it to x's and y's, right? But how can you do it without switching it to an equation with x and y? And there's a way, okay? So if we want to find the derivative of y with respect to x, okay, what we're going to do is we're going to take the dy over dx, and we're going to multiply it. Okay, so that these are differentials. So dy is a differential, dx is differential. And what we're going to multiply is the differential of 1 over dt and 1 over dt. Okay, so dy over dx, this is the version of 1. Okay, and then this becomes dy times 1 over dt, which is dy over dt over, and this one becomes dx over dt. Okay, so how do you find the derivative of y with respect to x? All you have to do is take the derivative of your parametric function for y and take the derivative with respect to t, and that's your numerator. And how do you get the denominator? Well, you have to take your x equals equation, right? Your x in terms of t, and take the derivative of that with respect to time, and that's your denominator. And that's it. That's all you have to do, okay? So dy, let's kind of put one big formula in here. Dy over dx is equivalent to dy over dt over dx over dt. And that's how you find the derivative with respect to the derivative of y with respect to x, okay? Now, okay, so that tells you the slope of the tangent line, right? Okay. Now, how do you find this? How do you find the second derivative? How do you find multiple derivatives? Okay. So we want to know what is the second derivative of y, okay, with respect to x for the second time, okay? Okay. So, okay, this d stands for the derivative for the second time, right? So this becomes d dt over dx over dt, and this means dx over dt times dx over dt. So times dx over dt, okay? And this is dy over dt. Okay, so this is dy over dx, and what we're doing is we're taking the derivative with respect to time and the derivative of x with respect to time, okay? So we're taking the derivative of this, that'd be the second derivative of y with respect to time for the second time, right? Okay? So then this is going to equal d dt times dy over dt over dx over dt times dx over dt. Okay, now what I want to multiply by is dt over dx. And this is going to be a version of 1. So dt over dx over dt over dx. Okay? So right here, this dt and this dt are going to cancel out because dt over dx and dt over dx, this is a version of 1. Okay? So this dt and this dt cancel. Okay? And then this dt cancels with this dt, and this dx cancels with this dx. And what you wind up is the derivative with respect to time of dy over dx. Okay? So d dt, that's this, of dy over dx over, okay, and then this would just be dx over dt. Okay, so what the heck does this mean? Okay, so to find the second derivative, what you have to do is you have to find the first derivative, that's this one, right? And then we have to take the derivative with respect to time of that and then divide that by the derivative of the x, the value, the x in terms of t, right? We got to take the derivative of x with respect to time, okay? So this right here is the derivative of the first derivative. This numerator is the derivative of the first derivative with respect to t. So whatever we get right here, we're going to put right here and take the derivative with respect to time, and then the denominator is just going to be dx over dt. Okay? All right, so let's do some problems. We'll do 2 problems and we'll be done with this, okay? I know it's the graphing part that takes a long time, okay? This parametric function thing, the derivatives, it really just doesn't take that long, okay? Okay, so now for the calculus, okay? So if x is equal to t squared plus t and y is equal to t squared minus t, find dy over dx and then the second derivative of y with respect to x for the second time, okay? So the very get-go, we need to find dx over dt, okay? So dx over dt is equal to, that would just be 2t plus 1. And then we also need to find dy over dt. And dy over dt would be 2t minus 1. Okay? So dy over dx is equivalent to dy over dt over dx over dt. That would mean this would be equal to 2t minus 1 over 2t plus 1. We's done. We're done with the first derivative, okay? Now we got to do the second derivative, okay? So the second derivative of y with respect to x for the second time, right? That's equal to d dt of dy over dx, right? Which is 2t minus 1 over 2t plus 1. Over dx over dt. And dx over dt is just 2t plus 1. Okay, now we got to take the derivative of this, okay? So we got to take the derivative of this with respect to time, and it's going to be over this one, right? Okay, we have to use the quotient rule on this, okay? So the derivative of the top would be 2 times the bottom, 2t plus 1, minus the top, 2t minus 1, times the derivative of the bottom, which would be, with respect to time, which would be 2, all over the bottom, the denominator, right? 2t plus 1 squared. All over, this fraction bar is this one, okay? And then 2t plus 1. Okay, now we could clear the fraction out, right? We could multiply top and bottom by 2t plus 1 squared, right? And so this is equivalent to, and I'm going to distribute at the same time, okay? So this would be 4t plus 2. Okay, and I want to distribute a negative 2. So negative 4t, and then negative 2 times negative 1 would be positive 2, right? So negative 4t plus 2. All over, and I'm multiplying this and this, this and this by 2t plus 1 squared, which would give you 2t plus 1 cubed, okay? And then cleaning this up, 2 plus 2 would be 4, right? So this comes out to be 4 over 2t plus 1 cubed, okay? And that's the second derivative. Okay, let's go to example 5. Okay, so if x is equal to 2 cosine t and y is equal to cosine of 2t, find dy over dx, and then the second derivative of y with respect to x for the second time. So that means we got to find dx over dt. Okay, so this would be 2 times the derivative of cosine t, which would be derivative of cosine is negative sine of t. And then dy over dt. Actually, let's clean this up. This would be equal to negative 2 sine of t. Okay, and then dy over dt would be the derivative of cosine, which would be negative sine of 2t times 2, or negative 2 sine of 2t. Okay, all right, so dy over dx, and I showed more work than you really need to do on the last one, okay? So dy over dx would be this derivative over this one, right? So it'd be negative 2 sine of 2t over negative 2 sine t. Okay, now the negative 2's cancel, right? And we're left with sine of 2t over sine of t. Hey, do you remember a trig identity? Yep, we did one earlier, right? Sine of 2t is equivalent to 2 sine of t cosine of t over sine of t. Sine of t's cancel, and you're left with 2 cosine of t. Okay, that's the derivative. Okay, and that's these are equivalent. Okay, so you're not going to have, it's the same, and so you want to do these trig identities because look what it came down to, something simple. So when we go to the second derivative, man, that's going to be easy. Okay, so here we go. So the second derivative of y with respect to x for the second time is going to be the derivative with respect to t of dy over dx, which is 2 cosine t, over dx over dt. And dx over dt is just this negative 2 sine t. Okay, so what's the derivative of 2 cosine t with respect to time? Well, it'd be 2 times negative sine of t over negative 2 sine of t. Well, heck, that'd be negative 2 sine t over negative 2 sine t. Those are identical, right? The second derivative is just 1. Okay? And that's how you do these. That's how you do derivatives of parametric functions. Okay? All right? Hopefully this kind of made sense to you guys. This was a long lesson. I want to apologize. These are going to be long lessons. Okay? We only have 6 of them and we're done. So if we, you just have 6 of them to do. If you're not planning on taking the next calculus class after BC, I wouldn't worry about doing these. To be honest with you, I mean, if you want to do them. But if you pass the AP exam or the BC exam, you're going to be placed in the next calculus class, okay? And they're going to assume that you know how to do this, okay? So if you have the inkling, like I'm planning on, I'm pretty sure I passed it, okay? All right. Then you want to do these assignments, okay? So you're not going into your next math class already behind, okay? All right. Okay, so let me get the assignment sheet and I'll tell you what to do for today. Okay, so what I want you to do is actually I think it's assignment 12. This is unit 12. I forgot to change these assignment numbers, okay? So don't worry about the assignment number, okay? Page 541 and then 1 through 15 odd, okay? And that's all I want you to do, just 1 through 15 odd. All right, and I think that's 7 problems. Okay, and a lot of them is just like, and I've given you graph paper. Okay, so there should be graph paper in that packet. I'll attach PDFs to the Google Classroom too. Okay. All right, guys. So that's it. Just 6 more assignments. Okay, 6 more assignments, and we are done for the year. Okay. So my plan is to do this today. This is Wednesday, and then Thursday, Friday, and then Monday, Tuesday, Wednesday, and we is done. Okay, we are done. All right. You guys, and then so if you want to hold off, and I think they're asking you to turn your books in by the end of next week, you could do that. Okay. Also turn in your calculators and all that kind of stuff. Okay. And I think that's about it, guys. Okay. All right, tomorrow's more calculus. Okay, I think it'll go. It probably will go. It's been a couple years since I've done this. The next lesson, I think it'll go a little bit faster than today. Okay, I know today's. I'm guessing it's going to be like an hour or so. All right, I could be wrong too. Okay, all right, you guys. You take care. Proud of you. I know yesterday was tough. I know some of the submissions that some of you guys struggled with submitting it. And I'll send you guys a link if you want to try to appeal and try to do a makeup in June. And I would do it if you think I know the calculus, I just didn't get a chance to show what I know. Then I would definitely put in for that makeup test in June. Okay, because you might as well go into college ahead of the game. Okay. All right, you guys, you take care. Have a great, blessed day. Take care. Bye.